Okay, friends and neighbors, in the previous build, we put two phones together, but they were on the same exchange. They were sort of part of the same call server. You might say the same office, the same switch. This time what we're going to do is extend this to create what we call a dial pair. So let's label our diagram a little bit. So you may recall that we sort of divided things up like this. We said, well, we had the 10 and the 11 net. Whoops, let's do this. We had sort of this router divided in half. We had a switch divided in half. We had maybe VLAN 10 over here, VLAN 11. We said that as an example, one phone was going to be 475.1111 maybe, and that we had a network associated with this of 11.0/24. And over here, we had, whoops, 10.0/24, something like this. And then that means that we need to extend this a little bit bigger. So what I did was I said, well, I don't really need the 10 net. That was really for testing. So I'm going to move the 10 net here. Right? So I'm going to get rid of this down here. And I'm not really using, the PCs anymore. So I'm going to move my 10 net up here. I'm going to create this link between the two sides on the 10 net. Maybe I'll do that. And then on this side, what I'm going to do for the phones is I'm going to create a DHCP pool and a network address. We still need our VLAN, right? To do this right, we still need a VLAN. But I think I'll use the 12 net over here. So we'll say that this will be 192.168.12.0, and it'll be on VLAN 12. And the phones on this side will use a different exchange. We'll call them 476, and we'll make this ePhone 3. So we're going to say 476, maybe 3333, so that we can see how this works. Now, we got to notice a couple things here. Not only am I incrementing the numbers in a kind of a silly way, but the important part is that the extension is going to be different. Okay? Now that we're going to interconnect here with an Ethernet connection, so this will be the 10 net. So now we'll have 3 networks, so that means we need to do a little static routing. So we need to add that, and we're going to go ahead and configure this other call server. Now to save a little bit of time in the video here, I'm going to go ahead and configure that other call server, and I'll get back to you when it is working. Okay, I think we're about ready to go with the next part of our configuration, but let's do a little cleanup here. So if we take a look at our config on the router, I suppose I ought to go to the router. Let's find out what our router knows. So if I do a show IP route, this router knows about its networks, and that's it. So that's one thing we got to fix. The other thing we got to fix is something I forgot about, and that is our DHCP excluded addresses. So we know that we've got this set of networks that we're giving out, or the IP addresses that go on those networks, but we don't want to give out any of our servers or any of our statically configured IP addresses. And so the way that you avoid that is you say something like this. And you say, well, what do I want to exclude? What do I not want to give out? And in this case, it's pretty straightforward. I don't want to give out my 2 routers. Now, if I had other servers or things like that, I would exclude those as well. PCs, anything that had a statically configured IP address. And other than that, I'm in pretty good shape. Okay, so now let's fix our routing. Now we look at our diagram here, and I'll just add a couple of IP addresses. This is 254 here, and on the other router I made this 253. And then here, of course, we have 192.168.12.254. And over here, on the inside network, we have 11.254 on this side. Okay, so what we need to do is fix connectivity across the way. And so the way that we're going to do that is with some static routing. So I'm going to say I want to get to the 12 net. Maybe I'll move this up a little bit, center it. What network am I trying to get to? Well, I'm trying to get to the 12 net. Whoops. 12 net. And the mask for the 12 net is just /24. And then how am I going to get there? Well, the interface that I'm going to use to get there is 10.253. Okay. And hopefully I remember to do that on the other router. Let's see how that changes our routing table. And we can see that we've got this static route here. Now, if all is well, I should be able to get that other router on the other side. Now, the important part about that is not only can I get there, but can it come back? And it can. Now, what this means is that I should be able to set up dial peers. I can set up all the dial peers that I want, but if my routing doesn't work, my straight up layer 3 routing doesn't work, my phone calls aren't going to work either because it's voice over IP. Now, the nice thing to remember, or that helps me remember about dial peers too, is that dial peers are just like the static route that I set up. What I'm going to do is say, I'm looking to get to a particular dial pattern. How do I get there? Well, I'm going to get there via a particular IP address. So let's do that now. So what we're going to do is set up a dial peer. So we have a couple of options here. We're going to be setting up a dial peer. Well, what kind of dial peer? Well, it's going to be voice. And what we need is some way to identify which peer this is, because you could have a bunch of these. This is our first one. And what is it going to be over? Right? We're going to be doing voice over IP. And that about does it. Well, that about does it for sort of the name. Well, what do we want to do? As I said, we're setting up sort of a default route, and so to this particular dial pattern. And so what we're after is, what does the pattern look like? What is it? What is the dial pattern that we're looking for? And we can see here we're looking for something called, or that begins with 476. So we're going to need this destination pattern right here. But we're also going to need this session target. We're going to need this because that's the IP address that we're going to. So what are we after? We're after a pattern. So the pattern in this case is 476. Now, it's also nice to specify the length, because some extensions, if you're internal, you don't always use 7 digits like I used here. So I'm going to say that, by the way, this is 7 digits. Okay. Well, the session target, who am I going to talk to? This will be who will route to the call server for me. And we can see that we're after a particular target, right? So we have a couple of options. Well, who is this going to be? Well, the session target will be, the other guy. And I've got a couple of examples here that I've used, right? Here. So we can do the same thing. We're going to be after an IP version 4 destination. And then who is my destination going to be? Well, we know that is the 10 net. It's on the other side. There we go. And that about does it for this dial peer. But I didn't set up the dial peer on the other side, so let me do that too. Now, I don't necessarily have to set up the dial peer on the other side. I just did that for completeness, right? If I want to be able to call over there, that's one thing. But if they want to be able to call back, they need a dial peer too. So let's give this a whirl. So I'm on 475.11.11, and I'm going to dial 476.3333. And I'll let you listen in here. Sounds pretty good. So there's our phone calls working just fine. Let's do two other things here. Let's see what's going on in between the two sides, okay? And then let's also switch over to a T1. Now, before we do that, let's just recover or recap what we've done, right? So I got rid of the 10 net on this side, and I decided to redirect it to the middle here. So I've got 3 networks. I had to set up static routing. I set up another call server with a completely different set of phone numbers, as we see over here. So another ePhone on a different call server. So I have 2 call servers in my topology right now. We've got a call server here and a call server here. By the way, just for fun, on this call server, I set this up without sending the SBN or loads files because the phones were already updated. I didn't actually need them. I just set it up to do the CNF files, and that was it. And that's by default. So the phones go automatically to their call server to ask for the CNF file. So I set up the static routing, and then we set up something called a dial peer. Right? So we have a dial peer on this side and a dial peer on the other side. And what that is constructed of is we have a target that we're trying to hit, an IP address, and then a dial pattern. In this case, 476 going that way and 475 coming this way. Well, let's switch over our monitor sessions real quick. You may recall that in the previous video, I set up a monitor session. Whoops, I didn't set it up on the router. Let's go over to the switch. All right, we're on the switch. So if I do a show monitor here, we can see that I am tracking port 11 and I'm sending that to port 23. But now I'm going to watch somebody else. Now to do that, right now I've got this point-to-point link between my routers. So I'm going to get a little tricky and I'm going to reroute this to my switch. And so what I'm going to sort of do is it's going to gum up my diagram here, but I'm just going to reroute this down to my switch. Let's use a different color. Oh, I don't know. To show what I'm doing here, we'll use, hopefully y'all can see this okay. I'm going to send this down to my switch again, and maybe I'll even send it into port 11 like I did before. And then I'm going to send it over here. So all that I'm doing is really sticking the switch back in between the two networks, okay? And so we'll see how that works here in a second. So hang on one second. I decided not to use port 11 because that'll gum up the works a little bit. So we'll undo our monitor and then we'll redo it. But I'm also going to sort of undo this a little bit here. What I really did was I sent this, maybe to here, and then back across. So same idea. But the 2 ports that are in question here is that this was port 19 and this is port, what did I use, 21. But I've still got my monitor in 23. So let's do this. I'm going to say that. Let's say no monitor session 1 source interface F0/11. And instead, I'm going to say I want 19. So now the fun is going to be, well, what happens when let's get rid of that, start a new capture. What happens when I look at what's going on in between the 2 routers? And so I'm going to go ahead and make that same phone call and we'll see what happens. And maybe what I'll do is answer it this time. All right, so now we have a whole bunch of RTP traffic. And the reason that we sometimes get confused when we're doing Cisco is that Cisco doesn't do a standard call like everybody else does. I'm going to go ahead and hang up now. Now, Cisco uses the skinny client control protocol for its signaling, but that's not what's going on here. We can see in the beginning of this that we've got H.225, which is part of H.323. So what we have in between two call servers is a different signaling protocol. Still using RTP for transport, and this is much more standard. And we can also see the codec there, G.729. But this is using a different signaling protocol. So what's interesting about this is that if we take a look at the signaling protocol, and again, my diagram is getting a little clouded here, but the signaling protocol here was SCCP. The signaling protocol over here, SCCP. But in between, we have H.323, which is comprised of H.225, H.245, H.35, or 235. So that is the fun part about interconnecting call servers. And there we have it. Now we see what's going on in between. But let's do one more thing. Let's go ahead and convert this center link to a T carrier. All right, so we're in the middle of converting our Ethernet link between our two routers to a T1. So on this diagram, what that means is that this whole link, if we remember that we had on this side 192.168.11.0, and over here we had 192.168.12.0, and in the middle we had 192.168, the 10 net. Well, we're still going to have the 10 net, but we just have to futz around with something that we're not used to, which is a T1. And so there's a couple of things that we need to remember. I'm going to put a text file on the side here to show us, or to remind us what we're going to do. So this is what we're actually after. This is a config that I had a lot of stuff going on here today, but there we go. So this is what we're after initially. Now I've already set up the other router, so I don't have to keep running over there. But what we're going to do is set up this side of a T1 link. And what I've done is unplugged Ethernet, and we'll test it by pinging here. So the first thing that I'm going to do is I'm going to show you something that you may not have been aware of, that, the sort of under the hood thing is something called a controller. And we can see that I've got an actual T1 line card in there. By the way, don't swap. Be careful whether or not you're allowed to swap those out, whether or not they're hot or cold, and whether or not power is applied. So I've got this T1 line card. Now, the other thing that we have to remember is that a T1 is actually a serial connection. So while we're going to be configuring the parameters of the T1 with T1 commands, with controller commands, we have to remember that it's a serial link, and so we need to configure a serial interface as well. So let's do this. So the first thing I'm going to do, controller T1, but then what? Which T1 are we dealing with here? So it looks like this one is in slot 1. And so we can see that we have now our options as we always would have. And we're going to do a couple things. So let me pull this over to the side here. So this is what I'm worried about. Well, a T1 is a multiplex connection. And so this first thing we've got is framing. Well, I've said ESF here. Now this is the default framing type, and what ESF means is extended superframe, which means that we're going to be using up to 24 time slots. But we're just specifying this. It's the default on a lot of systems. Line code. Well, I've got B8ZS. Well, what does that mean? That's called binary 8-0 substitution, and it's how we handle sort of ones and zeros on the line. There are a couple of encoding schemes, but binary 8-0 substitution is fairly common. Now, the T1 has 24 time slots. Now, you can create what we call fractional T1s. We're going to make a full T1, and we're going to allocate it to this connection between the two routers because we could have a lot of traffic. And so I'm going to create a channel group 1. What am I going to put in channel group 1? Well, I'm going to put all my T1 time slots. Now, this is an indication that I could have more than one channel group, right? Okay, there we go. That about does it for our T1 basic configuration. And look what just popped up, this serial interface. So we've got some sub interfaces that we can create here. So let's go ahead and finish the configuration. And all that this means is that, oh, you just configured my parameters. I can now talk to the other side. So we're going to exit this and let's go to the serial interface. Which serial interface? Well, 0, 1, 0, and we're going to do the colon one here. We've already really configured the parameters for the serial interface. All that we really need to do is to give it an IP address. And remember that we took away the Ethernet, but I didn't fix the router config yet. So let's see what happens when I try to use the same IP address. So I'm going to say IP address 192.168.10.254. Now the link is down. We'll see if we can get away with it. Oh no! So what I'm going to do is we'll go to int of 0/0 and we'll say no IP address. Okay, and then we'll go right back to the serial interface and we'll put that on there. There we go. And that'll be it. So well, actually, let's take a look at our routing table. Show IP route. See what things look like there. So we have this static route, right? Same thing here. We have this directly connected via this very strange interface right there. So this is introducing us to another kind of interface. It's sometimes seen when we're dealing with WAN connections or stuff like that, sometimes backup connections. Let's try to ping that other side. 10.253. Looks pretty good. Let's try to get beyond it. We'll see if our static route holds up. Because I didn't change the static routing on this side, I still have the same IP address. I just moved it to a serial interface, right? This guy here. So let's see if we can get to the router interface on the other side. And that was 254, I think. Whoops. That's not going to work. There we go. And there we have it. So now our phones are interconnected via T interfaces instead of Ethernet. Now, the problem with T's, of course, is that you need a T1 analyzer or something like that. You can't do simple packet traffic like I did before, which is why I did Ethernet first so that we could see the packet traffic in between the routers, which was H.323. Well, there we go. So let's recap real quick, right? We started off with an Ethernet connection between them, and we set up dial pairs, and then we converted over to a T1. Well, a T1 has lots of configuration parameters, but a T1 is really a serial link. So we go and put the IP address on the serial link, and we're ready to go. Well, thanks for watching. Thanks for listening. I hope that this demonstration helped you with some of your understanding and maybe some of the things you can do on your old builds. And remember, hey, this is networking. You can do this.